There are a few points that I want to discuss here which are important. First of all, let's discuss how f0 works in the first place, right? So f0 gets 5 and then do what with it? What happens that f0 of f, your function, comma 5, your function has one input now, t, right? T is the only input to your function. Do you agree with me? So f0 will put this 5 as an input for the function and evaluates what's the value of the function. Then changes that 5 to some other value, 4.2. Plugs it into your function and see what's the output. Then changes and plugs it into the function. Then changes and plugs it into the function. It will continue doing that until your value of f is very close to 0. That's when it stops. Does it make sense? Does it make sense how f0 works? So plugs in value and change the value, plugs in, change, plugs in, change, until your function value is 0. So for question number 2, if I want to define my function, v would be equal to, first of all, let's do inline function. 30, okay, let me increase the font. Inline of 30 times cosine of pi over 4 times t minus 0.5 times 9.8 times t. I put a dot here just in case if I wanted to evaluate my function for many t values, I can do that. If I run this now, you'll see that we have v of t. So we have one input to this function, right? I have v of t. I have a function v. The name of my function is v. And I have one input to that, which is t. Is this clear so far? What I now do is I do f0 of my function. My function is v, so f0 of f, f0 of v, because my function is v, comma, starting point, 1. I get a value of t equal to 0, basically, which is not the okay, I'm not getting the same value that you guys were getting. What?
Minus 10.
Oh, why don't you say anything then? Just wanted to let me fail, huh? Okay. So f0 of v comma 1, that's the first time that my projectile reaches 10 meters. And if I plug in like 4, I have a 3.79. That's the projectile goes up, comes back. That's when it reaches 10 again. Does it make sense so far? Now I want to try another thing. Instead of plugging in values, I want to define my v0 as 30. I want to define theta as pi over 4, and I want to plug the values or plug the variables in instead of the values. Let's do that now. So v0 is 30. Theta is pi over 4, and g is 9.8, right? Now if I want to define my function v, instead of 30 I put what? v0. Instead of pi over 4, I put theta. Instead of 9.8, I put g. Now when I evaluate this function, there are multiple inputs to the function. Although g, theta, and v0 are defined, when you want to evaluate your function, you have to pass those variables to your function. Remember? These are all inputs to your function now. You got to pass them to the function. Now if I use f0, like I did before, f0 of v comma 4, it will fail because there is not enough inputs to the inline function. Although theta is defined, g is defined, and v0 is defined, it's not passing them into the function. The only thing that is given to the function is this 4, and 4 represents what variable? T. So only t is now given to my function. Function cannot be evaluated. Right? There are 4 inputs to my function, and only one of them is passed to that function. The other 3, although they're defined, they're not given to the function. So function cannot be evaluated. Does it make sense? If I want to do this way, it means that when I do f0, I have to pass all the inputs to my function. So all the inputs, see what I did? I copied and pasted. Why did I copy and paste? Because the order of inputs are important. Define your function, just copy and paste it from MATLAB into your f0. Now the issue is, I have g, I have theta, I have v0. If I run this, it wouldn't still run. It said undefined function or variable t, because f0 is now confused. I have so many inputs. What am I looking for? Right? I know that the function should look for t, but this is a machine. Machine doesn't know which one of those variables should it look for. Right? That's where you tell the machine what you're looking for. At sign t, it means that I'm looking for t. So if I come back and say at sign t, it means that among all the inputs that you have, I'm looking for t. At sign t, v is the name of the function, and then all the inputs come of 4. It means that give t a value of 4, start it in, and then change t until you find the value of this function equal to 0. If I start at 1, I get the other. Does it make sense? Yes, Sama.
Yeah, my function is not working.
Yes. Let me stop this now. So what it says is that you can measure the flow using a Weir, and this is the equation that you can use. Q is equal to K, which is 0.4 plus 0.05 times H over P times 2G, square root of 2G times L times H to the power of 3 over 2. So P is this one, this height of your Weir. H is the height of water on top of that, and L is the width of your Weir. Given, well, if P is given as 2, G is given as 32.2, and L as 15, what's the value of H if Q is 200? So basically you have 200 equal to K times the square root of 2G times L times H to the power of 3 over 2.
Then
You want to find?
You move it to the right. And
Absolutely.
The same thing.
Same thing. You move Q, that's 200 to the other side. The only issue here is K is this. You can just plug in K into your equation. Having two inline functions is not going to work. Inline functions cannot call one another. So if you define K as an inline function and then you define q being inline of k times square root of 2g, it's not going to work. Because if there's a variable inline function, we would call it in. If there's another inline function, it cannot do. So let me start defining that function. Clear CLC bless you. G is 32.2. P is what? 2.
2.
L is 15. Is that correct? L is
Yes. Yes.
And what other variables do I have?
200.
Q is 200. Well, that's 200 goes into the function. So I call my function Q. You want to call it F? Go ahead and call it F. So F, let me call it F actually. F is inline of what? K, which is 0.4 plus 0.05 times H divided by P. 0.4 plus 0.05 times H dot divided by P. And then this is K, so the entire thing should be multiplied, right? So I need a parenthesis around it. If I don't put the parenthesis, that plus sign is going to be evaluated separately. We don't want that. And then dot times square root of 2g times L is QRT of 2 times g dot times L dot times H dot to the power of 1.5. If I do 3.3 over 2, do I need a parenthesis over 3 over 2?
No.
Absolutely. Otherwise, it will raise it to the power of 3 and then divide it by 2, not to the power of 1.5.
Why are you doing dot times L?
Because if I want to evaluate it for several numbers, if I want to plot this, I need those dots.
I just thought you would only do it for H, because that was.
Well, what if L is multiple values? Putting dots there wouldn't hurt if you don't have them, and if you want to evaluate them as a vector, it will help. So basically, that's more or less a preference than anything else. Does it make sense so far? I have a negative 200 as well, right? Because my Q is equal to 200. Yes.
Can you add parentheses around the H divided by P?
You can. You don't need to. So if you want to add a parenthesis around this, you can. You don't need it because that's times, that's division, same order of calculation, wouldn't change it. Negative 200 at the end, and that's your function. Now f0, I want to find the root of this function. So I just copy and paste this entire thing. See, I didn't put a semicolon at the end, so it writes this to the screen, and it goes with H, L, P, and G. Where is this order coming from? Why is it not f of L, comma H, comma P, comma G? Why is it H, comma L, comma P, comma G? Where is that order coming from?
The function.
Yeah, that's the function, but I have H first and then P. The first variable that I have in my function is H. The second variable is P. Why is it f of H, comma L, comma P, not H, comma P, comma L? Alphabetical order. Uppercase and then lowercase. Alphabetical order of the uppercase ones, and then alphabetical order of the lowercase ones. The only issue is, don't ever try to find what are the order of inputs. Evaluate it, write it to the screen, copy and paste. Alright? Don't ever do things manually. And then the starting point of, I start with 4. What am I missing here? The at sign. I'm not telling which variable I'm looking for. At sign, I'm looking for h, right? At sign h, 2.357. You're not getting the same answer? Alright, let me stop this. So the question asks, estimate the uniform flow depths in a concrete channel using Manning's equation, which is Q equal to this, given the following properties. Width is 4, the slope is 0.002, and roughness coefficient is 0.015, and those who took fluids are like, yeah, of course, we know all this. For flows between 20 and 50, plot depths y versus q. So for each q, you have one y, right? As depth increases, flow increases. Do you agree with me? Boise River, when it is flowing really high, flow is higher than now that it is really low, right? So elevation y has a relationship with q. Y goes up, q goes up. The issue is you are dealing with A, which is basically width. A is the area, which is width times depth. W times y. W you have, y you don't have. And then R is A over P. A is what? W times y. P is the wetted perimeter. W plus y plus y. W plus 2y. Right? Let me draw it here. So you have a channel. You have a W here. You have a Y here. What's the area? Area is W times Y. What is the wetted perimeter? So this is width, this is width, this is width, right? Upper side is not width, that's air. W plus 2y. That's the wetted perimeter. A, you have already. R is A over P, which is W times Y divided by W plus 2y. Do you agree? So, my Q it's really hard to erase this. Alright, so my Q would be what? 1 over n. N is defined, right? No problem. Times A, which is W times Y. Is that correct? Done. Times R, which is WY divided by W plus 2y to the power of 2 over 2 times S0 is given, right? So that's my function. I have W, I have N, I have S0. I'm looking for Y. For each Q value, I have one Y value, right? Now, I take Q to the other side. This becomes my equation minus Q equal to 0. So that's my function now. My function is this equation, Manning's equation, minus Q equal to 0. If I define this, I will have to solve this equation for various Q values. Q is changing between 20 and 50. So for each Q value, I have to find one Y. So F0 for each Q value. Let's get to this. Let's go step by step. Let me define my function first. Let me open up a new script actually. W is equal to what? 4. What else do I have? S0 is equal to what? 0.002. That's a rough surface. What else do I have? N is what? 0.015. Perfect. So these are the given ones. Now let's define my function. F is inline of this 1 over n times W times Y times, do I need a parenthesis around this? Absolutely. To the power of 2 over 3. Now let's plug in the values that we have. W times Y divided by parenthesis W plus 2 times Y. Do I need a parenthesis over W times Y? I don't need to, I can have one. So if it gives you any consolation to have a parenthesis over there, plug it in. Otherwise, you don't need to. Do I need a parenthesis over here? Absolutely. Because this W plus 2 times Y, they're all in the denominator. If you don't put a parenthesis over that, it will be W times Y divided by W. So basically becomes Y plus 2 times Y. Does it make sense so far? Times S0 to the power of 0.5 minus Q. So that's my inline function now. If I evaluate this, I have a function which is a function of Q, S0, W, N, and Y. If I use F0 here, that's my function, my input. Let's start with initial point, let's start with 3. I'm looking for what? I'm looking for Y. Now the issue is, do I have a Q defined? No. Not yet. Let me, just to start, let me define Q as 20. For Q equal to 20, Y is equal to what? 1.75. For a Q equal to 50, the upper bound, Y is equal to what? 3.55. So for each Q value, I will have one Y value. Does it make sense? So basically, if I have a for loop, if I have a bunch of q values, if I have a for loop and if I go over each of the q values, I can find the y value for each q value. Does it make sense? So if I define down here, if I define q is linear space of 20 to 50, I will have 100 values between 20 and 50, right? For q. So for I from 1 to 20, I have a problem here. The problem is my input q should be one value. This is now 100 values. So let me define it as small q. So the vector q I defined as lowercase q. And then here I define uppercase q is basically element I of lowercase q. Yes?
Why is it I 1 through 20 and not I through 30?
1 through 100. Neither of them. Because I have 100 q values. Right? For each q value, I want to find the y value. Right? I have 100 q values in the vector lowercase q. Each time I take one value of that vector lowercase q and put it in uppercase q. I evaluate this function and that gives me one y value. I put an n, I will run this. The issue that I have here is that it will write them to the screen, but you will not have a vector of y values. See, if I run it here, this is what I have. For q equal to 50, y is 3.55. For q equal to 49.69, y is 3.53. For q of 49.39, y is 3.52, right? So for each q value, I have one y value. Does it make sense so far? The only issue is I haven't saved those y values, right? They are written to the screen. I don't have them. I don't have any record of those y values. So I call it y of I equal to f0. This y of all equal to f0, what it does is that it will keep track of all those y values that I calculated. So if I run this again, and if I do plot q comma y, well, lowercase q, uppercase y. That's a little sloppy, but anyway. So this is my q values between 20 and 50, and this is my y values. As q increases, y also increases. Any general question that you might have? Yes.
So if you don't suppress the output to the YY thing, you get like columns 1 through 10, and like 1 through, all the columns that come out of it.
If I don't suppress right here?
Yeah.
What will happen? Let's see. Yeah, what happens is that, each time, so for the first one, you only have one y value, right? That one y value will be written. For the second one, you had the first one, and you're adding the second one, so 2 will be shown. The third round, you had the first 2, and the third one is added, so 3 will be shown. So the length of the vector is increasing each time. Suppress the output writing, so it doesn't mess up your screen. Let me stop the recording right now.